Hello, my name is Paul Kiesling, and today I'm going to be presenting with my colleague Arnav Joseph on the topic of increasing awareness of NASA's CubeSat launch initiative in order to enhance STEM opportunities for all. We are representing the Wolfpack CubeSat development team, which was the first satellite middle school team to ever build, test, and launch our own their own CubeSat, and we were able to perform this amazing feat through NASA's CubeSat launch initiative. But first, what even is NASA's CubeSat Launch Initiative? NASA's CubeSat Launch Initiative is a platform that provides educational institutions the resources in order to build and launch their own satellites. Since its inception, the NASA's CubeSat Launch Initiative has launched over 100 satellites from a variety of states in the United States of America. One of these satellites was from the Wolfpack CubeSat development team, the WISat-1, which was launched on December 3rd, 2018. Additionally, recently we got another proposal accepted, the CapSat-1 satellite, which we are currently building, and that will be launched in 2021. NASA's CubeSat launch initiative is able to ignite the students' STEM interest and attract and retain students in STEM disciplines. This is current However, this is currently very important to the aerospace industry, as there's been a lack of hands-on STEM education. And this has been a problem for many years, as studies going as far back as 2001. However, aerospace succession planning is more important now than ever before due to the graying workforce. In 2018 alone, the aerospace sector generated over $928 billion in revenue and represented over 20% of the nation's manufacturing workforce. However, as aerospace professionals continue to retire and the quality of education continues to decline, we could be seeing a major crisis in the coming years. Additionally, educating our future workforce goes hand in hand with NASA's Strategic Objective 3.3 to inspire and engage students. The process of inspiring and engaged students comes from the STEM pipeline, which is essentially the process in which students are exposed to education relating to STEM, all the way from elementary school in their younger years to when they graduate college and are preparing for a career path in STEM. However, this pipeline is currently fractured due to the lack of hands-on STEM education in early years. And this lack of preparedness leads to a faded interest in the STEM fields, as students cannot easily grasp the subjects when they don't have a foundation. And that foundation is necessary to be built early through hands-on education in order for them to excel in the future and eventually perform hands-on learning activities in a career in STEM. But why is hands-on learning so important? Well, hands-on learning was developed by the most prominent educational philosopher of his era, John Dewey, through his progressive education theory. In this theory, he stated that students must interact with their environment and learn by doing, not simply by a passive lecture environment. This, he states, will improve the overall long-term retention of student information and further excel them in the classroom. This has been proven through numerous studies that show that hands-on learning is directly correlated towards improved results within the classroom and therefore an increased interest in STEM fields. The Wolfpack CubeSat development team is a big believer in this approach to education as we design, build, test, and launch satellites. As I mentioned previously, we are the first middle school in the nation to have been accepted by NASA's CubeSat launch initiative and subsequently launched a satellite. The first satellite which we launched was the WISat-1 on December 3rd, 2018 at California's Vandenberg Air Force Base. Additionally, based on that success, we were able to write another proposal to NASA, the CapSat-1, and this satellite is expected to be launched in 2021. As you can see to the photos on the right, at integration for the WISat-1, the students are hands-only interacting with their object, which they're about to send to space, the WISat-1. And this is the true essence of hands-on learning. Through the WISat-1, the students also have very good practical work experiences with the certification, testing, and integration of the WISat-1. They had to conduct many different testing and were very involved in the breakout and vibrational tests conducted at Kennedy Space Center in obtaining the Federal Communications Commission's amateur experimental radio license, and then finally integrating the satellite spaceflight headquarters in Seattle. On top of this, there are many other tests which you can see on this slide. And based off of the success of the WISeSat-1, the students were able to write 6 more proposals to NASA's CubeSat launch initiative the following years, based off of the lessons learned and the hands-on knowledge which they obtained through the WISeSat-1 experiment. And this year, 3 other proposals are being written to NASA's CubeSat launch initiative, and the students are working in teams with the co-investigator leading the proposal. There's a minimum of 10 letters of support for each team. And one of the best parts of the experience of writing a proposal is the required preliminary design review, which we conducted on October 24th, 2020 at Kennedy Space Center. This has been igniting the STEM interest for life for most of our students. And now here's Arnav to tell you why diversity is so important in the aerospace industry.
Thank you, Paul. According to Career Explorer, only 18% of all aerospace engineers are female, while 82% are men. According to the United States Center of Education Statistics, 14% of students, that is about 9 million students, don't even have internet access. According to the Bureau of Labor Statistics, only 4.9% of people coming from lower socioeconomic backgrounds have high-paying careers. As you can see in the chart represented in the slide, there is a very low representation of people from other racial and ethnic backgrounds in STEM careers. Asian STEM careers are a close second to whites, but are still 1/3 of the white population of STEM careers. We really need to do something to bring about a diversity and increase the involvement of Blacks, Hispanics, and other races. Next slide, please. Here are some issues with STEM knowledge and education. Underprivileged students lack access to STEM knowledge and in education. According to the Advocate, low-income students rarely own computers, let alone a good internet package. Not many students are aware of STEM education programs, nor understand how to navigate their way through. Another issue that adds on to this is that their poor and uneducated families are unable to help these children pursue their dreams. There is a huge digital divide between fortunate peers and less fortunate students. According to CIRIC, there's a huge shortage of women in aerospace and STEM. Next slide, please. Here is why the STEM pipeline needs to increase with more racial and ethnic minds, and why students will be determined to pursue great careers. Students will be determined to pursue great careers because they would know that this opportunity would only come once in a lifetime. The STEM pipeline is breaking because there's a loss of racial and ethnic minds. They're important because they can inspire new ideas, innovate, and create new technology that can impact the society using the combination of science, technology, engineering, and mathematics. Next slide, please. Now let's look at some ideas that will help these children. This can be done through various community-based STEM programs. We could organize some free events that includes hands-on learning. We can also conduct some free after-school activities. This is probably the most effective way to educate the less fortunate students. And another important idea is to provide incentives for qualified STEM educators. Now I will give it to Paul to talk about how we are trying to increase educational opportunities for all.
Currently, the Wolfpack CubeSat development team is very involved in the Aerospace Public Policy Institute, where they're able to create hands-on STEM opportunities for all. As part of this, students were very involved in the writing of House Resolution 85, which was reintroduced to Congress earlier this year. This legislation is aimed at increasing awareness for NASA's STEM programs, mainly the CubeSat launch initiative, which helped to ignite STEM interest in the students of the Wolfpack CubeSat development team, and hopefully this can overflow into other diversified students. We are currently in the process of gaining support from states that have a positive educational experience from CubeSats. And we're corresponding with US representatives and senators at a variety of legislative blitzes in order to directly increase awareness for STEM and for our legislation. In conclusion, the fractured STEM pipeline is putting the future aerospace industry at a risk, and it must be addressed at its core. Students have to be exposed to hands-on STEM opportunities from an early age. And NASA's CubeSat launch initiative is one of the best ways in order to engage students in actually building, testing, and launching their own satellite. In order to do this, the Wolfpack CubeSat development team has been very involved in advocating to enact this change by increasing public awareness of these types of opportunities. Thank you.